Hello and welcome. In this video, I'm going to take a few moments and show you how to use Ohm's law to do calculations. Hopefully in your reading you learned about Ohm's law, and up till now in our COVID-19 shelter-in-place distance learning assignments, you have not had to do calculations. But inevitably, in physics, calculations come. So let's get to it so this video isn't too long. Okay, so the essential question, how does current relate to resistance in a circuit? We're going to use Ohm's law. First of all, let me quickly run through what the symbols are to make sure you understand. Current. For current, we use the symbol I. And we talk about how the electric charges are flowing in the circuit. The unit for measuring current is amps or amperes. Now, the speed of electric charges within a circuit can be affected by several things, like the type of wire or the length or the thickness of the wire. The current can also be affected by the voltage provided by the power source, either battery or the power source on the wall. That voltage does affect how much current's flowing. When the voltage increases, the current will also increase. And as you learned in the last section, an ammeter is a device that we use to measure current. We could have direct current, where it's always in the same direction. For example, when we use batteries. We could have alternating current. That's where the electrons reverse the direction of flow 60 times per second, or maybe some different amount. And an example of that would be the electricity in our home. Another thing that we measure is the voltage. The voltage is sometimes called the potential difference. That refers to the push that actually makes the electrons flow. The electrons have that potential to flow, but they won't unless the circuit is complete or there's something that provides that push. A difference between the energy levels is needed, and we call that difference voltage, or we measure it in volts. The symbol is the capital V, and we measure it with a voltmeter. So voltage is pretty simple. It's a pretty easy concept to remember because everything has to do with volts. The only confusing part for some students is when we use the word potential difference. I just want you to remember it means the same thing as voltage. And the last quantity that we use to measure in Ohm's law is resistance. That's anything that will oppose the flow of the electrons. This one is often harder for students to remember. The unit is measured in ohms. It's a Greek letter omega is the symbol for our unit. The symbol for resistance itself in the formula is the letter R. Okay, so just like we say, we measure distance, letter D, in meters, M. Okay, so we measure resistance, letter R, in ohms, omega. You would encounter the highest resistance in things that are either poor conductors, like wood. If you stick a piece of wood in a circuit, it's going to resist the flow a lot, and it's not going to flow very well at all. If you have really thin wires, they provide a lot of resistance, or if they're really long. Now let's look at Ohm's law. The law itself relates current, voltage, and resistance. We say voltage V is equivalent to the current I times the resistance. Okay, and so now let's go ahead and see if we have enough time to get to a few calculations. I'm going to take my video of my face off, so you're seeing just the screen. Hold on. Okay, and that didn't work, so hold on just a second. The picture of myself, so I just moved it over. Let's look at example 1. It says calculate the voltage across a 3 ohm resistor if a ½ amp current is flowing through it. Okay, so the first step we want to identify is which quantity goes with which. All right, and we're going to say that the 3 ohms, I know what's measured in ohms, that would be my resistance. So 3 is going to go here under, I'm having trouble with my pen. Let's see if I can delete that. Under resistance, there we go. And then the 0.5 amps, that's going to be current. So that will be my letter I. 1/2 an amp times 3 ohms. So my voltage will be, what is half of 3? 1.5. And how do we measure voltage? In volts. So my answer would be 1.5 volts. Okay, let's look at the next slide. Example 2. A radio with a resistance of 240 ohms, so that's going to be my R value. It's plugged into a 120 volt outlet. Incidentally, most of the outlets in America are 120. In Europe, you might find that they are 240, which means when you plug in your household appliances, they get burned up in Europe if they're from America. Anyway, okay, what is the current flowing through the outlet? Let's see. I'm going to do 120 in place of the volts, and the current I don't know, so I'm going to leave that as an I, and the resistance is 240. All right, how do I solve for I? What would I do? I need to get I by itself, so I'm going to divide both sides by 240. 240. I actually write much neater than this. It's just learning how to do this on here. Okay, so 120 divided by 240, I can see that those are multiples of each other, and it looks like the current, oh, that's a terrible I. The current is 0.5 amps. That's an A. Okay, and then finally, my third example. What is the resistance when 6 amps of current, so that's my I value, is flowing through a circuit with 120 volts? That's my V. Now here I don't have my equation. I'm going to have to look it up. V equals I R. So that's Ohm's law. In place of V, I'm going to put the 120. In place of I, I'm going to put the 6 amps, and I'm looking for the resistance. How would I get the resistance? How do I get the R by itself? Divide both sides by 6. I can see 120 divided by 6 is going to be 20. And what is the unit to measure resistance? That's one we just learned. Ohms. We use the Greek letter omega. And that is how we calculate Ohm's law. Hopefully this will help you complete this worksheet. What I want you to do is go ahead and go through, and you can just type it out. You don't have to try to write like I was with the mouse. It's a little cumbersome. Type out your work to show your work. Use your calculator and submit it on Teams. As always, if you're having trouble, please send your teacher a message on Remind or an email. Happy learning.